Welcome to Ask and Learn.
So we have three metal plates, and two of them are connected to ground, like this. And then we stick one in the middle. So this is D and 2D. And we know the charge on the middle one is Q. So I'm going to say this is Q1 and Q2, where they're both negative since the middle one is positive. So it's really minus, but I'll account for that at the end. And we have two capacitors, C1 and C2, which are going to be A times epsilon naught over D, and the same, but with double the separation distance. So we know, first of all, that the total charge is the sum of Q1 and Q2, and again, we're working in magnitudes here since Q1 and Q2 are negative. We also know that the charge for any capacitor is the capacitance times the voltage. So we can say that the voltage is charge over capacitance. And now I'll call this V1 and V2. And we know the potential for either capacitor has to be the same since they're both connected to ground, right? So I can substitute in Q and C. This is Q1 over C1, and this is Q2 over C2. So this means that we have Q1 over A epsilon naught over D, and this is Q2 over A epsilon naught over 2D. So we have Q1 times D over A epsilon naught is 2Q2 D over A epsilon naught. So the D cancels and the denominators cancel. So we have Q1 equals 2Q2. And we also know that the sum has to be Q. So we can say that 2Q2 plus Q2 equals Q. So Q2 is, we have 1/3 Q. And that means that Q1 has to be 2/3 Q. And they're both actually negative, so we put that there. And now, to find the potential, it's going to be the same either way we do it. It doesn't matter which one we choose, since they're equal. So I'll say V1 is Q1 over C1, which is Q1 over A epsilon naught over D. So this is Q1D over A epsilon naught, and Q1 is minus 2/3 Q, but we'll just stick with magnitudes here. So this is 2QD over 3A epsilon naught.